Thank you, Claire, and thank you to the Royal Institute of Navigation and the Resilient Navigation and Timing Foundation for their support in establishing this webinar. Thanks also to GPS World, the Institute of Navigation, and the Maritime Executive for their sponsorship. So this is the first MarRINav webinar, but we hope not the last, as Claire has suggested, and we'll touch on that a little bit more at the end. What is a MarRINav? We're all going to do it when GNSS fails, apparently. You'll be pleased to learn that it's not a new style of dance. It's actually the title we gave to a program of work that's exploring the issues of resilience and integrity in position, navigation, and timing from the maritime user perspective specifically. MarRINav is a program of activity that's been funded by the European Space Agency's NAVISP program. And I'll put a link to their website at the end so you can visit their online home to learn more about their work. The lessons we've learned in phase 1 of MarRINav have given a clear indication that not only are those PNT issues very real for the mariner, but that terrestrial concerns could equally take note from the journey that we've been on and the direction that we're advocating. And I'll touch on some of MarRINav phase 2 and beyond in due course. I think, first of all, thinking maritime, I'll give you a little bit of context. So we have a very busy and complex sea space. If you look at this vessel traffic density from marinetraffic.com, it gives you an idea of just how busy the sea space is. And this is focused, this is focused on the UK specifically, the phase 1 of MarRINav. But that darkest red area is showing 400,000 tracks within a given year within that given area. It's perhaps no surprise that the densely populated part of this relatively affluent part of Northern Europe has such a busy marine environment. And not least when you consider that the global fleet's almost doubled in size since 2005. That brings us something close to 90,000 ships moving cargo. But that doesn't include the pleasure craft and the fishing vessels and the ferries and the cruise ships and all the other vessels that are out there. So this is an increasingly busy space, not just a busy space, but an increasingly busy space. It's a valuable space too. So from a UK perspective, 500 million tons of cargo are handled by UK ports each year, and 95% of all UK imports and exports go by sea. And they're going on larger vessels. So it's an increasingly concentrated amount of value, if you like. Since the late 1960s, vessels have increased about tenfold in size. The largest of them carrying over 20,000 containers. And the picture here, which is of HMM Algeciras, is the largest container ship at the moment. If I'd done this presentation a year ago, I might have referred to a different vessel like Marco Polo, for example. But this particular vessel is 23,000 containers, or in excess of 23,000 containers. So giving you a sense that really these vessels are carrying value approaching the GDP of a small country. Container freight's a major part of the UK economy, but we're not unique. The same applies to many nations around the globe. So we've got a busy and a high value sea space that we're talking about here as part of the MarRINav program, MarRINav focus area. It's not just that it's busy, and it's not just that it's high value, it's also complicated. The sea isn't just being used for vessels anymore. So in the UK, back in 2000, which doesn't seem that long ago, Blythe offshore wind farm opened with 2 turbines. It was decommissioned last year, but over those last 20 years, around another 1,200 more turbines have been sited offshore in the UK alone. So that's 1,200 new challenges to navigation. And they feature alongside new aquaculture sites, newly designated marine protected areas with boundaries that are relatively easy to define on a polygon, but are a lot more difficult when you're interpreting them at sea from a mariner perspective. And another complexity that we're dealing with now in the maritime space is the rise of the machines. 10 years ago, autonomous vessels were akin to remote-controlled speedboats, or maybe science vessels, more aligned to something like a maneuverable buoy or buoy, as you might say on the western side of the pond. If you read the news, it's clear really that autonomous vessels are making their mark and appear to be an increasingly established feature of the maritime environment. So by the start of 2019, as an example, we were mobilizing phase 1 of MarRINav. The Falco ferry was being demonstrated in Finland, the picture here. This was a full demonstration of a passenger and a car ferry that was in essence remote controlled. The captain could be about 30 miles away. So this is a complex, busy, high value, highly changeable sea space. PNT, of course, being a groundbreaking element that's revolutionizing the industry in all those examples that I mentioned. So we're racing forward. The mariner has to have confidence in the accuracy of their navigational aids to be able to operate safely. It looks like that's a trend that's set to continue. So from a MarRINav perspective, we were building on the work of the General Lighthouse Authorities of the United Kingdom and Ireland, plus the London Economics Report of the UK economic impact of the loss of GNSS, and the UK government's Blackett report on GNSS vulnerabilities. That London Economics Report placed a cost of £1 billion on the loss of GNSS over 5 days, directly related to maritime. The total cost placed upon a 5-day GNSS outage in the UK was estimated just over 5 billion. So maritime being about 20%. It underlines the fact that PNT is not just a maritime concern. And those losses, it's important to make the point in the report that those losses refer to the direct impacts, not wider impacts, sort of ripple effects through the economy. So substantial numbers we're talking about. Alongside those obvious safety implications, there's that big economic impact too. So MarRINav is about understanding those important, complex, safety-critical maritime needs. I just take a moment to underline that the situation here is focused on the UK and Irish territorial waters. We're primarily looking at a sovereign solution, given obvious unknowns to the UK from a sort of geopolitical perspective there. However, we're looking for a solution that is consistent with international regulations and standards, and that works with international movement and trade associated with shipping. So although it's UK centric, we're very cognizant that the traffic coming in and out is coming from all over the world. I think it's worth sharing the project build up with you. So I'd like to introduce the team from MarRINav phase 1. There were 9 organizations that we worked with. NLA International Limited was the prime. It's a company where I'm a director. And we led delivering of the project management and coordination, as well as supporting user needs activity, bringing a maritime perspective, some aspects of the communications and the road mapping of the future project phases. The General Lighthouse Authorities provided technical leadership and undertook performance analysis. And as Claire mentioned, Dr. Alan Grant is from the research and development, the GLA's research and development team. He's with us today to answer questions and share his insights also. A key member of the GLA team, I think I'd really like to take a moment to mention, is George Shaw. He's definitely deserves a special mention for his role as program architect for MarRINav. We worked with the Knowledge Transfer Network, which is part of Innovate UK, and they led on user and stakeholder engagement. London Economics performed the cost-benefit analysis for us. The University of Nottingham led the EGNOS and integrity simulation. University College London helped develop the hybrid solutions for resilience. Terrafix supported the development of future architecture. And BMT provided simulation for port pilot analysis. Taylor Airy provided expertise in consulting, drawing on their knowledge of PNT as a critical national infrastructure. But perhaps importantly, it's really interesting to note that they were bringing knowledge from the aviation sector. And quite often PNT is, from a maritime perspective, is kind of bundled together. And actually having aviation experts on board really helped us understand and assess the difference between the domains, of which there are substantial differences in the user needs. Another important point to make, I think, is that each of the organizations brought something different to the table, but crucially, none of the organizations were out to sell a solution. We were not pushing an agenda or an outcome. We were not solutioneering. We were analyzing real needs and reconciling them against data and simulations to reveal where GNSS was at risk of being unable to meet specific maritime user needs. I'll elaborate on the user needs in a mo as well. So if you jump to the next slide here, and I'll give you a sense of the way the project was broken down into 8 work packages. So each work package was led by an organization and a named individual within that organization. The whole project was built on a premise that we would embrace a spirit of collaborative challenge. So many work packages had key inputs and dependencies on others, with individuals nominated for peer review and to provide support to one another. It's a complex problem, and so I really can't stress the importance of the behavior of collaboration enough. There was a real need for the team to come together and discuss. MarRINav just couldn't have delivered without the relationship between team members. Transactional email-based relationships probably wouldn't have given us what we needed. To challenge each other was an important element of the project, and it helped drive quality into the findings of the report, or all of the reports. That challenge needed a trust and a rapport to be established, and so the project management work package was crucial as a vehicle for setting time, cost, and quality standards, but it also set a culture and a tone, a behavioral tone for the project. So the work package elements were work package 0 was project management. Work package 1 was about understanding user needs and the required levels of performance, and I'll expand on that further to give you a sense of that. Work package 2 was about satellite based augmentation systems, SBAS, and beacons for GNSS integrity. Work package 3 looked at resilience and integrity technologies and their integration. Work package 4 was about developing a conceptual architecture for future PNT infrastructure that blends space and terrestrial solutions as they were being identified by the project. So you can see that idea of the we're learning, identifying solutions, and then working out how to meld them together. So there's sort of an iterative cycle, an iterative loop in the development of the way the project was delivered. Work package 5 was a cost-benefit analysis of those proposed solutions as we started to mature them and solidify our thoughts towards the end of the project. Work package 6 was about stakeholder engagement, so bringing in the right external people to constantly challenge and validate the findings as we went through the process. Work package 7 was about planning and road mapping, so we could tell the story about where we wanted to go in the future. I've said that, and I will now jump into work package 1 in a little bit more detail, because it really is a foundation element of the project, understanding the user need to be knowledge led about user requirements. We explored PNT needs at several stages, and if you think about this as a journey of a vessel, out on the high seas, approaching land, approaching port, meeting a port pilot, entering the port, docking, transfer of cargo off the vessel, and then that cargo making its way out through the port gates. That's that journey from out at sea to the cargo actually being off the vessel and at the port gates, leaving to go on its terrestrial journey was the journey that we looked at. So this analysis gave us a set of user needs, and it wasn't just a paper exercise. We interviewed experts and current end users. So those experts, we had ship's captains, we had port pilots, we had port operators, hydrographers, navigators, we had regulators. We brought all these people together in workshop environments so that we could hear of real examples and capture and compare their perspectives. I need to mention someone else by name now. General Lighthouse Authority's Paul Williams deserves a mention here. He was curating all these findings with a tremendous degree of fortitude. We initially, I think, envisaged it was a relatively straightforward data collection exercise, and it revealed itself to be a much, much more substantial undertaking that resulted in an in-depth analysis. It's all captured in the report that, along with the other reports that are available to download from the website. But this user requirements document, as a standalone document, is a 200-page document. Everything's available to be downloaded. It's freely available to be downloaded from MarRInav.com. MarRInav.com, MarRInav.com, 2 R's. I'll put the web app address at the end, of course, as well. But that user requirements document is really quite substantial, and I think underlines the level of diligence that was applied to understanding user needs. So it was the foundation of our work, you could say. But what we then had to do was overlay actual performance of the component parts of the current GNSS and the wider PNT solutions. We went to the IMO regulations as a baseline standard to determine what was needed where. So you may be aware, if you're in the maritime space, that the International Maritime Organization, the IMO, defines integrity as the ability to provide users with warnings within a specified time when the system should not be used for navigation. For the purpose of MarRInav, we defined resilience separately as the ability to anticipate, mitigate, and recover from a disruption. So here we're considering two different things: integrity and resilience. And I think that's quite important to sort of pause and recognize the difference, with essentially ensuring that you can receive a signal, being what we would call resilience, and that the signal you receive is sufficiently precise for your specific user need, that being integrity. So we were making a distinction between the two, as they are quite often grouped together, but actually the technological challenges of resolving those issues is different, complementary but different. So those considerations were mapped against all of those user needs from that document that Paul curated out of Work Package 1. So just to touch on IMO Resolution A1046, which relates to International Maritime Organization's worldwide radio navigation system. It sets out a minimum performance standard for a GNSS to be considered as suitable to use. It's not really setting out user needs per se, but it's considered alongside a 915 IMO Resolution 915, which is about future GNSS requirements, as a good source of guidance as to what the performance needs to be. And you can see how it works. I mean, I'll skip onto it and put it up on screen. But if you can see that in ocean water, they're looking for 100-meter accuracy, 95% availability, harbour entrance approaches and coastal waters, 10-meter at 95%, and also there's an update interval there at 2 seconds in both, signal availability of 99.8%, so on and so forth. So there's a set of criteria there, and I'll again, all this is in the report, so don't feel like you've got to copy the slides out. But the if I move to IMO Resolution A915, there's that minimum user requirement for general navigation, and as in the last one, there's the various zones: ocean, coastal, port approach with restricted waters, into port, inland waterways, and what's required in terms of the alert limits, the time to alarm, and so forth, and so on. So there's a set of user requirements in there. Okay. So that's probably a good bit of context and a good bit from the user perspective. I'd just like to give you a sense of the technologies and the depth of the technologies that we looked into. And as we've alluded to already, we will touch in more detail on the technical side of things. But for now, let me give a quick overview. Broadly, we're going to categorize them as global, wide area or regional level, local area, and then specific to being on board the vessel. So thank you, Dana, and team here for the graphic, which sort of illustrates this and builds this layered approach here. And again, as with everything, detail on each system is available within the MarRInav reports. And in this specific instance, I'll guide you towards deliverable 4, which is PNT, R&I technologies and integration. So again, if you want to read up on this particular section in more detail, that's where to look. So we started by listing all the different PNT sources that had been considered in previous reports, such as the Blackett, the London Economics, and the European Radio Navigation Plan. And then considering global systems first, we recognize that GNSS will remain the primary positioning system, but, and it's a big but, we're interested really in meeting the requirements in those times and in those places where GNSS are not available. So that led us to consider SATALIS, system timing location, so STL. At a wide area or regional level, we looked at other technologies from the report, such as ELA-RAN. At a local level, systems such as RF mode, MF and VDE, and systems such as Locata in ports. The project added to those by including systems being developed by the GLA, such as radar, absolute positioning, and ePolaris as well. So ultimately, we looked at onboard methods, so down to the very vessel specific. So traditional methods of navigation, inertial dead reckoning, and of course, as you'd expect, multi-system receivers. Clearly, all those systems are at different technology maturity levels. So a little bit of temporal context here. The MarRINav timeframe is looking out to the 2030 window. So we're considering how mature some of those technologies might be by the point in time of 2030, rather than where they are today. I'll expand on all of those a little bit more in case people aren't familiar with the individual technologies. So that global level, we said we're looking at GNSS and STL. So if we're considering the four constellations, the GNSS constellation, the four mainly recognized GNSS constellations, and their expected evolutions, how they'll progress, and considering the use of GPS and Galileo when using SBAS. So for us in Europe, EGNOS, augmentation of the data. STL uses low Earth orbit satellites, which, as you probably already realize, have an orbital pattern a long way beneath that of the GNSS constellations. So they also have a stronger signal, and they use a Doppler positioning approach as a differentiator. But fewer satellites are tracked at one time, and performance is largely unknown at this time, but it's coming. It's a technology that's coming. Excuse me. So at that wide area, or that regional level, we're looking at ELA-RAN. So it's a low frequency terrestrial transmission, a strong transmit power with a large coverage area, sort of in the region of 1,000 kilometers. It's a proven technology. It's capable of providing up to or sub 10 meter accuracies for ports and harbors, and sub 30 meter beyond range of reference station. And it also provides an accurate timing signal. So position and timing, assuming you have the right configuration. And on the point of configuration, other than Anthorn up there, almost in the middle of the blue ring, the other sites are a suggested set of locations to give an ideal from the UK rather than actual locations. So yeah, if you want, you'll be disappointed if you go aerial spotting to some of those places, although Anthorn's there. Thinking now at that more local level, VDES R mode. So VHF data exchange system, effectively an upgrade to existing AIS base stations, as shown on the image on the left there with the dots on it. With the addition of a ranging capability to enable positioning, the project considered that all UK AIS automatic identification system AIS base stations are upgraded to a VDES R mode. So you could expect accuracies in the order of 10 to 100 meters, and so there are areas where this is useful augmentation, and other areas where geography and topography limits its utility. And in the middle map there, down on the east coast of the UK, the coverage is pretty poor. So again, no one system here fixing everything. And then the other consideration at this local level is radar absolute positioning. So radar conventionally providing range and bearing to a target, and in that an active method using e-raycons to return one's own position, and the passive method using knowledge of the expected radar picture. So again, expecting accuracies there in the order of sub 20 meters. So in ports, we looked at Locata, which is a terrestrial positioning technology. It's a nanosecond timing synchronization. It transmits like GPS type signal, but over a very local area. So you get very good accuracy. Accuracy is in the order of sub 1 meter. So that was explored. And then on ships specifically, dead reckoning. So traditional speed and log gyro-based approaches, inertial measurement unit, which is quite good over short term. Radar could be used for as part of a dead reckoning approach, so radar dead reckoning, and we consider all approaches will be integrated with some sort of dead reckoning system. And then, of course, multi-system receiver, so IMO receiver standard, to allow the use of all GNSS augmentation of terrestrial signals. Also, and the IMO reference there, IMO MSC .401, in case you wanted to look it up. So quite a thorough look through some technologies, I hope you'd agree. Taking those needs from that work package 1 and overlaying all of those technologies, there's no answer. There's no individual technology or system that meets all the needs. And furthermore, even if you bring 2 systems together, you still can't meet all the needs. So much of the work has been done using simulations to assess the viability of each potential solution. As an example, the ELA-RAN model in the General Lighthouse Authority's gadget, as they call it, the gadget system, has been validated against real operational data. So as you're aware, we operated ELA-RAN in the UK up to the end of 2016. And the validation of the gadget system was done against real data. So arguably, a gadget offers the best ELA-RAN coverage model in the world. Happy to take a challenge on that. But so we're relatively confident. No, we're beyond that. I think we're very confident that the model allows accurate assessments and that the results are solid, delivered from that model specifically, as an example. Many of you will be familiar with the technology of RAIM, Receiver Autonomous Integrity Monitoring. So in essence, a device, in our instance, on a vessel, but in whatever the vehicle happens to be, and you'll be familiar with ARAIM, aviation RAIM, a device that compares all the signals and highlights any discrepancies that appear between them. So you can imagine a system bringing in 3 or 4 different signals, saying, "Hang on, one of these is wrong," then it can alert you to that. So MRAIM, Maritime RAIM development, will be a feature of the MarRINav Phase 2 activity. As part of Phase 1, the mathematical model for an MRAIM solution was peer-reviewed by Stanford University with a very positive validation. And again, those findings are all in the reports also. I keep talking about those reports. We've published them along with all the findings of Phase 1, so they can be accessed, so you can consider them. And we hope that the thinking in them will be developed by the global PNT community. So we'd be very much welcoming your feedback and input as you go through them. I should point out as well, on the topic of reports, that this particular section that we've just been talking about here, the integration, the MSR integration report, is deliverable 6. So have a look for D6 MSR integration report if you want to learn more about that. So as I've said, it didn't matter which signal source we examined or simulated. In each instance, we found gaps in either resilience or integrity, and no single system met all the user requirements. So no silver bullet. A system of systems was clearly required, and that's the next step now for MarRINav Phase 2. So, a proposed solution for UK critical national infrastructure. What does it look like? What could it be? So the project identified the need for a mix of GNSS, ELA-RAN, BDES-R mode, integrated with dead reckoning, supported by absolute radar positioning, in order to meet the UK's critical national infrastructure needs. So the principle is that the final position solution will be delivered from the dead reckoning system, which is calibrated by the other resilient PNT systems. So I've touched on phase 2 a couple of times, but mainly I've been talking about phase 1 and our findings. We're currently designing MarRINav phase 2. We're going to move from those early simulations to a demonstration to prove, to test the concepts proposed by phase 1. From an integrity perspective, as I've said, we want to learn from the aviation RAIM, that receiver autonomous integrity monitoring model, and explore the viability of a maritime or MRAIM solution. This capability will work with EGNOS and sit within a multi-signal receiver at the vessel end. From a resilience perspective, we want to lay the foundations for a system of systems PNT service that protects critical national infrastructure. It starts as a test bed, but very quickly we're aware that it must scale to an operational solution. So the MarRINav phase 2 project will demonstrate proof of concept for a practical and scalable solution for maritime integrity and resilience at user level. We'll maximize the effectiveness of Galileo and EGNOS to support the safe and efficient flow of trade and to protect the marine environment and to safeguard the lives of the mariners that we've put at the center of the study, the end users at sea. So a little bit more on phase 2. We've got the design of that's underway. We're currently making technical assessments of the potential partner capabilities and forming the team. So that's an activity that's ongoing, and indeed prior to this presentation it was something I was working on earlier today. So that's very much live and in the moment phase 2 coming together. At the beginning I've suggested that this is the first MarRINav webinar, but not the last. So I'm aware also that I've spoken at relatively high level, and that there will be many people in the audience who are hungry for a full course of technical detail. So we'll confirm details of the next session, and as Claire says, watch the social media channels for that, and the MarRINav website and the other vehicles, so we can alert you to when that's happening. But by way of a sort of technical amuse-bouche, we're fortunate to have Dr. Alan Grant with us today to field some of the more technical side of the questions. And while we do that, I did say I'd put the web addresses for you. So let me just pop that on the screen there. So visit marrinav.com, MARRINAV, marrinav.com, for more details of the project and to download any or all of the phase 1 reports. And also please visit navisp, navisp.esa.int, so navisp.esa.int, to learn more about the NAVIS program of the European Space Agency. That's it from me. Thank you very much, everyone, for listening. I'll hand back over to Claire, and we'll go into the Q&A session.
Fantastic. Thanks very much for that overview, Jonathan. Really helpful. So it's now time for us to ask Dr. Alan Grant to add some comments.
Okay, thank you, Claire, and thank you, Jonathan, for the good overview of the project. And hello, everybody. I'd like to take a few minutes just to draw some attention to some key areas of the project as I see it. We'll all have our own bits, I'm sure. The first is the approach. And as Jonathan said, we had a good team of partners which approached the project of trying to find what a critical national infrastructure for UK maritime may look like by using a systems engineering approach. So trying to understand the user requirements, and Jonathan's touched on the maritime requirements, and then map them to the available technologies and what we believe will be available in 2030 timeframe, but using a system engineering approach. So it gives us an unbiased, rigorous and justified assessment. And hopefully you can see that when you go through the different documents. It also then allows us to look at what it means to us in the UK. So we focused, as Jonathan says, the MarRINav phase 1 part of the project on the UK and Ireland, with our own very specific geographical and political constraints. So that means that we had a very concise point of view, and that might be different elsewhere. Resilient positioning, navigation and timing is clearly of interest to many different nations. There's lots going on around the world. For example, in the United States, it's a key point. It's a key point within the European Radio Navigation Plan, and of course, it's part of the IMO's e-navigation concept. The developed approach within MarRINav is scalable, and can be used in other countries with different constraints and opportunities, and across different transport modes. So we think that's one of the key findings really from the project, is the approach. Now, it's clear that different locations with different existing infrastructure, different coastlines, and allow for different geometric arrangements will allow for different solutions, and that's fine. There is no one size fits all. The UK solution may not be right for everybody else, but if we have a systems of systems approach combined with a receiver technology that can manage that, can use the different systems around, and such exists, then the approach works. We can actually fit within the international standards, the international framework and movement of shipping, and achieve resilient PNT in the long term. That's the goal. So by considering candidate PNT solutions in a global, regional, and then local manner, the overall infrastructure required should be more efficient and cost effective. And we show that in the cost benefit analysis in the report documents. So we recognise within phase one that, as Jonathan's already said, that the solution for the UK, what we're promoting is a GNSS, will be rightly the primary means of PNT information, but one that's supported by ELARAN, VDES R mode in those gaps where ELARAN can't quite meet the requirements on its own, along with radar absolute positioning, all integrated within the multi-system receiver supporting the dead reckoning position on the vessel. And then imports, Glocata being a positioning system that's probably more suited to static locations. Accuracy and integrity are key parts of information, and information that's needed by mariners today and become more important as we move to supporting autonomous vessels in the future. And as we said before, we consider both in MarRINav. Throughout the project, we've been looking at the different aspects of how these come together. What do they mean when you integrate and combine different solutions? And how does that feed through into the receiver integrity? We've talked about, or Jonathan's already introduced, the Maritime Receiver Autonomous Integrity Monitoring work, the Maritime MRAIN, something we think could greatly improve integrity as we go forward. Now, that's not all done and dusted and finished. There's more to be done, and I'm not going to go into the detail, but if it's something you're interested in, have a look at deliverable D3B. It's all mapped out in there. So finally, what I want to try to say is studies like this are great, but the overall intent is to move resilient PNT from being a discussion and a study to something that's realized on the ship. And we recognize that within MarRINav. And that's actually outlined in deliverable D10, where we have a roadmap of the tasks and actions needed to take it forward and to allow it to happen. Something that sits on the shelf doesn't help the mariner. Actually getting it out there is the important bit. We believe that through the systems of systems concept and the use of things like the IMO's multi-system receiver performance standard that already exists, this can actually be realized over the next few years. Thank you.
Excellent. Thanks very much, Alan, for adding that layer of detail. I'll now invite Dana Goward to expand even further.
Well, thanks, Claire, and thanks, Alan and Jonathan, and thank you to everybody on the MarRINav team. A very comprehensive, complete and thorough effort. I have to say I've not read all 1,174 pages, but I recommend it to everyone. And I can tell you that whenever I wanted to find information about something, it was there, and there's plenty of it. What do they think of Loran or Satellus? What about user needs? What can be done to better leverage existing satellite signals? It's all right there in the reports. And there's various versions of the reports too, depending upon the level of complexity that you want to get into, everywhere from an abstract down to a lengthy main report that has all the details. So thanks and congratulations to everybody. Very, very well done. As we all know, relying on space to the point where it's a single point of failure is dangerous. And sooner or later, it's going to cause the West big problems. Russia, China, South Korea, Saudi Arabia, and Iran have already recognized this and already include terrestrial PNT in their architectures. That the West is only coming to this realization right now is close to negligent complexity or complacency in my mind. Among the first lessons of the prudent navigator is that he or she uses every available means to determine position. We have lots more means available now than we are using. Getting some of them in place will require energizing political and business leadership so that everyone understands both the severity of the threat and then they are motivated to act to protect their nations and their organizations from disaster. MarRInav is a great tool in this effort. I encourage all of the attendees on this webinar to use it when they're talking to policymakers and folks who can help bring these ideas to fruition. Wield it like a club if need be, so you get them to see the light. Certainly, if you print it out at over 1,100 pages, it's a formidable weapon, but it is more importantly a formidable intellectual weapon that has more credibility than virtually any effort that I have seen heretofore. So well done, everybody, and let's get to some questions, because that's always the most popular part, and we're looking forward to that. And I think we're going to document all of the questions and the answers in text someplace on the website. So for those of you that are viewing this in archive, that will be available as well.